Today we're going to talk about dilutions, and a dilution is a way for us to take a concentrated solution and make it so that it is not quite as concentrated. So that means that there are less moles of solute per the amount of solvent. So the way that we do that is by adding water. So basically what we're doing is we're increasing the amount of solvent but keeping the same amount of solute, right? We're adding water. We know that water is usually our solvent. And so we are diluting it because, again, our moles of solute are staying the same, but we have increased the volume of water. Okay, so the equation that we use is this equation for our dilutions. M stands for molarity, so our concentration, and V stands for volume. Now, it doesn't matter the unit that volume is in, as long as V1 and V2 have the same unit. So our common units that we are going to see here are milliliters or liters. You just have to make sure that your V1 and your V2 are the same unit. So basically what we're doing here is we're taking our initial volume and molarity and setting that equal to our new molarity and volume. So what it started at and what we are getting to. So let's go ahead and do an example problem. So here it says, create 250 milliliters of a 3 molar solution using a 15 molar solution. So we can set up our little chart, 1, 2, MV. Okay, so it says we're trying to create 250 milliliters. So if we're trying to create it, that's our new. So volume is 250 milliliters of a 3 molar solution. So the 250 milliliters goes with the 3 molar. So that is also our new. So this is what we're trying to create. And it says that we're using a 15 molar solution. So that's what we're starting with. So our missing piece here is our volume. We need to figure out how many milliliters of this original solution we need to create our new solution. So let's go ahead and plug it into our equation. So we know that M1 times V1 is equal to M2 times V2. So our M1 was 15 molar. Our V2 is our X, is equal to 3 molar times 250 milliliters. Okay, so in order to get X by itself, we divide both sides by 15, and then we solve. So X is equal to 3 times 250 divided by 15. So it tells us that we need 15 milliliters of our original solution to create our new solution. Now, if we were doing this in the lab, our first step would be to solve the dilution equation, which we just did. That was our step 1. Okay. Step 2 is to take needed volume of original solution and add it to new sized volumetric flask. So we take 50 milliliters and we're going to put it into a flask that measures 250 milliliters. And then we are going to add water until desired volume. All right, so here we take 50 milliliters using our graduated cylinder. We have our volumetric flask that is a 250 milliliter. We pour this into here. So we end up with some. And then we fill with water until we're all the way up to 250. Okay, so that's how you do it in a lab. That's how you would solve this problem. So let's just go ahead and solve one more problem to make sure we have this down. Here it says, what volume of a 9 molar solution is needed to create 100 milliliters of a 1.5 molar solution? So again, let's figure out what we're starting with, what we are looking for. So what volume of a 9.0 molar solution is needed to create? Again, create always means that that is what we're going towards. A 100 milliliters, so that's what we're trying to create, of a 1.5 molar solution. So it's telling us that we're starting with 9.0 molar, so that's our beginning, and we want to know the volume that's associated with that. So again, M1V1 is equal to M2V2. Our original molarity is 9.0 molar. We're solving for X, which is our V1. 1.5 molar is our new concentration that we're looking for, and we're trying to create 100 milliliters of that. So we can divide both sides by 9. X is going to equal 1.5 times 100 divided by 9. So we need 16.7 milliliters of our original solution in order to dilute it.